Okay, so in this one, let's see how do you row reduce a matrix. So here we have matrix A. Zoom into this, and yeah. So we have matrix A here. This is a 3 by 4 matrix, the same one which we created in the first question. So what we want to do is we want to reduce this in the row reduced form. So what is you might ask, what is the significance of this matrix? Well, this can actually be the points in 3D space. So you can think of this as this being 3x plus y plus 2z equals 5. So that gives you a line in 3D space. And 1x plus 2y minus z equals 2. Now this is another line. Similarly, 4x plus 3y plus z equals 7. Now this is the third line. Now when we row reduce a matrix, what we basically do is we try to find the values of x, y and z. So to this row reduced form helps makes finding these values easier. So what exactly is row reduced form, and how do we get there? So first of all, the first entry here, non-zero entry, we consider this as the leading entry, and every element below that we have to make that zero using row operations. This is the same row operation which you have studied in class 12th, where we got the inverse of a matrix by reducing it by using row operations. So that would make this 3 and 0 and 0, and we would get different numbers depending on the operation which we do. And similarly, we have to then, so then in the second row this would be 0, this would be non-zero, or maybe 0 as well. So basically what we're trying to do is we need to get a triangle of zeros this way. So since there are only 3 rows, we are just restricted to uh, you know the triangle, restricted to zeros, and converting these numbers to zero, just that is 1, 4 and 3. So if we had a bigger matrix, then we would have to go all the way up to the end of the matrix. So let's see how we do this in Matlab. So let me just clear this out. Okay, so let me write down the matrix first. So this is 3 1 2 5 3 1 2 5 semicolon 1 2 minus 1 2 1 2 minus 1 and 2, and then 4 3 1 7 4 3 1 7. So let me just execute this. Yeah, you get this matrix. So how do you row reduce this? So as I said, the the first three, the three here, this 3 is the non-zero entry, and this is called the leading entry of this row, and we have to make these two entries 0. So how do we do that? Well, these we can do this by using simple row operations. If you look closer, for the second row, to make this 0, I can multiply the second row by 3 and subtract it from row 1. So how do we do that? So we to select the second row, this is the command that I write: a 2 comma colon. Now this just means that we are seconding the second row and nothing else, that's it. So but if we wrote it in this way, colon comma 2, we would be selecting the second column and nothing else. So since now we are interested in finding the second row, in converting the second row to be more precise, let's write it this way: 2 comma colon. Now this is 3 times the second row minus a 1 comma colon. Now this a 1 comma colon, as you might have expected, this represents the first row, this one. So let me go ahead and click execute here. Yeah, so as you can see, we converted the first element of the second row 0. Now similarly, we have to do this on the third row as well. Let me go ahead and do that. So we can first, let me select the third row. So it's 3 comma semicolon equals. Now what can we do to make this 4 0? Well, we can multiply the third row by 3 and the first row by 4 and subtract them. So what we are doing is 3, let me just select this, 3 times the third row. So how do you select the third row? So it's a brackets 3 comma colon. So now we have selected the third row minus 4 times a the first row. Okay, so here we have, let me execute this. Okay, great. So now we have these two zeros, these two converted to zeros. Okay, so as I said, now this, in the second row, the first non-zero entry is 5. So we have to make every element below that 0. So what do you have below that? There is this 5. So we have to make this 5 0. Now this is pretty simple. Select the third row, 3 comma equals minus the second row, because we have the same numbers here. So that would be, let me go ahead and execute that. Okay, fantastic. So we got 0 here, and in the next, which is the third row, we have all zeros. So we don't have to solve further. If we had a even bigger matrix, and we had this as the non-zero, every element below this we had to make it 0 using the same row operations. So now that we have gotten to the end, that is all this 0. Now what does this represent? Basically, as I said, every column represents a variable. So this, let me just show it here. Every column here represents a variable. So this is x, this is y, and this is z. So 4x plus 3y plus z equals 7. So but if you apply that here, it kind of, you get infinitely many values for x, y, and z, because 0x plus 0y plus 0z equals 0. So no matter what the values of x, y, and z are, it would still be 0, because the coefficients are 0. But usually this won't be the case, because when you row reduce this, you will be left with just one non-zero entry, which is the highlighted number here, which is actually right now 0. So with that, you would get the value of z. So it would be 0x plus 0y plus some value times z equals some value. So from there, you'd get the value of z. And in the second row, we have y and z as non-zero, and x is 0. So from here, you get the value of y. And in the first row, we have x, y, and z, and since we now know the value of x and y, we can get the value of, y and z, we can get the value of x. So this is how we row reduce a matrix, and I hope you got it. Thanks so much.